Hi, my name is Andrew McLaren, and I'm going to help you with a dilution problem, and then also a problem where we're mixing two different solutions and trying to figure out the final concentration when we have those two different solutions mixed. But to start us off, it helps to just do a simple dilution problem. So if you think about this, you're having some sort of problem where you originally have a molarity that's being provided, which is related to its moles over its liters. And this is just like the initial molarity and the initial liters and the initial moles. And we're going to be relating that to some sort of final situation where we have the final molarity, which is related to the final amount of moles and the final amount of liters. In this problem, they've provided for us the concentration. So we have a concentration value, and we also have a volume that's being provided. So it's in milliliters, so it's not exactly in liters, but it's something that we can work with. So from that, we can figure out the initial amount of moles. And then that initial amount of moles is actually something that we can use for our final amount of moles here, because this is just a simple dilution. Um, and we have actually the final amount of volume as well, so that you've got this final amount of volume. That should allow you to find this final concentration. There is a more condensed formula here, um, and we'll get to that in a second, but you can think about that's why this works. You're relating this stuff through the fact that the amount of moles is the same initial and final. So if we have 0.1027 molar HCl, we're going to be relating that to some amount of moles initial over this volume. Now, if it's 50 milliliters, 50 milliliters is going to be, what is that, 0.050 liters of the solution. And we can just do a simple calculation to get this number of moles. It's not too bad, but there's a little bit of math that we need to do. So 0.1027, and then times that by the 0.050, we get 0.005135 moles of this HCl being present. So that means that the number of dots here, that's our moles. That's still our number of moles in the final situation. So we can think about that with what I've got in this orange equation now as our number of moles. And that is over a new volume, which is at 250 milliliters, 0.250 liters. You can think about that if we're being technically correct with our molarity and putting it in the appropriate units. And that should give us our molarity. So we've got this number, divide that by the 0.250, and I'm getting something about 0.02054. And I know there's many math teachers who are like, you got to say that the correct way. Okay, no, I'm not going to. We're focusing on the chemistry for now. And you can see that this concentration is a bit different than what we originally had. This thing's volume has gone up by about 5 times, so its concentration has gone down to about a fifth of what it was, so like 20% of what it was. And you can kind of see that because this is, you can say like 10-ish, and then this is like 2-ish if we're talking about that place value right there, looking at 10 versus like the 2, so it's about 20%. What we can do, what you technically do in these dilution problems, is you can think about this as C1 times V1 is equal to C2 times V2, but that's because that is the number of moles. The number of moles, when you do the concentration times the volume, that gives you the number of moles. So if you just think about rearranging this equation, the initial amount of moles is equal to the final amount of moles. So you're just relating these two things through that relationship. So you can think about plugging in your numbers here for your concentration. The nice thing about this formula is that you don't necessarily have to use liters because the units cancel out on both sides of the equation. So if you're working with milliliters on both sides, that works out just fine. So I've got it written in liters, so I'm just going to use the liters number here. And we're solving for C2. So you can kind of plug in the numbers like so, and that should work out in a way where if you do the math, it's the same math that we just went over. C2 should come out like that. In other words, if this has gone up, the value of the volume, then the concentration's volume goes down. If this volume goes up, that concentration goes down when compared to the initial concentration of volume. So that's not too bad when we have just something being diluted. But when you mix two different solutions, you have to be a bit more careful. Because we have different volumes being involved, you can't just use this formula. You have to be a bit more careful as to what you're plugging in and where. So let's say that you have 3 molar of HCl and 6 molar of HCl. One is more concentrated than the other, and you're mixing them. Now I'm just going to tell you the answer right now with the numbers that we've got here is just straight dab in the middle, which should make sense because you are having equal volumes of the stuff, you're mixing it. And you can kind of see visually that this concentration looks like it's a little bit less than that and a little bit more than that, which should make sense to you. But in terms of the math, what you're going to want to do is think of your this is your 1 and this is your 2 in terms of concentrations and volumes and the moles that they are contributing. So there's some moles that are being contributed from this left one and some moles that are being contributed from the right one. You're going to need to add those together to figure out your final concentration. So if we do that, we've got our 3 molar HCl and it's being multiplied by 0.100 liters on this left side for that first one. So we're getting 0.3 moles of HCl. In a similar fashion, on this right side, you've got 6 molar HCl, and that is being multiplied by its volume of 0.100 liters, which is going to give you 0.3 moles of HCl. If we want to think about our amount of moles that are present here, you can add those two up. So you're getting 0.9 moles of HCl in this final solution. So the final solution here is it's going to be its concentration is equal to the moles over its volume. So the concentration final, volume final, moles final. We have the moles final, and we know the volume of the final solution because it's just these two other volumes added up. So if we wanted to think about that as that 0.200 liters, and our concentration was 0.9 moles of this thing, then you can see that this is going to be, what is that, 4.5 molarity for HCl. Or yes, I know I should be saying the chemical name, but again, we're focusing just on the dilution piece, so we're making it easy for students' brains at this point. So you get this final number that's right in the middle when we mix those two. Now, it does change a bit depending on how much volume you're using of these two solutions. So if I were to change the volume here and say that I actually have 200 milliliters of this solution, and I'm mixing it with 100 milliliters of this other solution, suddenly things are a bit different. So you've got like more solution here, and it's going to be similar in the math, but slightly different. So if this is now 0.200, this is now 0.6 moles of HCl being added to 0.6. So we're getting 1.2 moles of HCl. So our number ends up being slightly different. So you've got that 1.2 divided by 0.2. This is going to be 4.0 moles of HCl. In other words, if you have more of a certain concentration, it kind of brings down the average closer to that number. So if we have like a ton of this 3 molar solution, then we're going to be much closer to that concentration in the end with the math. So if I were to, instead of having 200 milliliters, let's say I've got 1000 milliliters, and I'm actually going to tweak this number to make this actually just 1 milliliter. So this is a very small amount of this stuff, a very, very small amount of this stuff compared to that stuff. And the end result is that we're going to have something that's basically the same concentration as what we had originally. So if we think about the math here, you've got 1 liter. So 3 times 1 liter is about 3 moles of HCl. And then this is 0.001. So this is a very small number. I think it's like 0.006. It's so small that it's insignificant in the big picture on this math. So if we have 3.006 moles of this stuff, you divide that by 1.001 liters, then you can see that this is effectively 3 molarity for the HCl, which should make sense because we only had this accurate to 1 sig-vig. You could say this is 3.00, I think, what is that, 2 or 6, something like that. But it ends up just rounding out to 3 because we're having so much more of this stuff than that stuff. The average ends up being very close to that concentration of that much larger solution. Yeah, let me know if you have any questions. Thank you for joining me.